So this is association rules, the second part, and this recording is going to explain how to mine frequent patterns without candidate generation. This means that it's going to do that through FP growth approach. So we're going to discuss or to have an overview of FP growth as an algorithm and its idea. And then we're going to go to explain what is FP growth and how do we generate frequent patterns from FP growth uh, and the steps that we need to do that. And this is going to be applied in an example. So an overview of FP growth. Now, the FP growth actually transforms the data set or the database that you're dealing with or the transaction set into an FP tree, which is a tree structure. It compacts the whole data set into a tree structure. This tree structure is actually highly compact, and however, it is complete, meaning that it contains all frequent patterns that we can observe in the data set. It actually also avoids the repeated dataset scans. So we actually scan the dataset only twice, no matter how big the dataset is. FP growth also develop an efficient FP tree based frequent pattern mining through a divide and conquer methodology. And as I said, it only generates um, um, uh, a part of the data set. It doesn't generate candidate data sets. So there are no subsets. It only generates the tree, and from the tree we're able to identify our frequent patterns. So how do we construct the FP tree? And in order to be able to use it to identify our frequent patterns. There are two steps to generating the FP3. The first step is to scan the whole transaction set for the first time, and then we generate is actually a list that consists of all the items that exist in the transaction set along with how many times they appeared. So these are the items in the data set along uh, along with their frequency. So here the presentation here I2 7 means that the item I2 appeared 7 times. Now the items that appear in L are those items that satisfy the minimum support support condition. In the case of the example that we're dealing with, the minimum support is 2. So if there is any item that has a frequency of 1, it does not show up in L. Now, also, L is actually arranged in a descending order, meaning that the item with the highest frequency appears first, and then the ones next, and then the one next, until we end up with the least frequent item. This is the data set, the transaction data set, consisting of 9 transactions, and each transaction contains a list of items. So this is the first step. We scan the dataset first to generate L along with their frequency and priority, which means order, in order to identify or generate the list L. So here are the items. Item 1 appeared 6 times. So if we count 1, 2, 3, 4, 5, 6. So it appears 6 times. Item 2 appeared 7 times. 1, 2, 3, 4, 5, 6, 7. Item 5 appeared 2 times, 1 and 2, and you won't find it anywhere else. Now, this order, as I said, is descending based on the frequency. However, if two items have the same frequency, you have the liberty to choose which has the highest priority. However, you need to stick to the same order, the same priority order in all coming steps. After that, we apply or we rearrange each transaction based on the priority order that we just generated. So this is I1, I2, I5. However, it will become I2, I1, I5 because I2 has the highest frequency in this list, in this transaction, I mean, and 5 has the lowest frequency. Now we start generating the FP tree by drawing the tree using each transaction at a time. So this is the first transaction, and we start by a null root. And we actually represent this transaction in a form of a path. So from null, in order to get to 5, we'll have to go to I1 once, I2 once, I1 once, and I5 once. Why we have a frequency of 1 here? Because in this transaction, we only have I2 appearing once. If there is another I1 element here, then here it will be I2, 2. The second transaction, which is I2 and 4, again, we're talking about path. From null, there is a path to I2. So we can have I2 and we will give it the frequency of 2, okay? And then from here, we don't have a direct path to I4, so we will create a branch here. So we'll have I4 and 1. Transaction 3, we also have I2, I3. This means that we will come to I2 and then I2 will become 3 because this is the third time that I2 appears. And then I3, we will create a specific path for I3, so it's I3 and I1 and 1. Now this is the fourth transaction, I4, I2, I1, I4. So I2, it will become 4 times. I1, it will become 2 times because we already had I1 here. And then I4, it will become 1 time. Notice that we have I4 here and I4 here. However, the way it's not the same path. So to get to I4 here, we'll go to I1 and then we'll get to I4. But to get to I4 here, we'll go through I2, I1, and then I4. Transaction 5 starts with I1. So we have to have a direct path from null to I1. Here, we don't get that path, so we'll have to come up with a new branch. So we'll have I1, 1, and I3, 1. This is transaction 6, starting with I2, I3. Null will go to I2, and then it's going to be 5. And I3, it will become 2 because this is the second time that we have the same transaction. I1, I3, it will go here, 2, and I3 also will become 2. I2, I1, and I3 and I5. So I2, I1, I3, I5. Null, it will go to I2, it will become 6. I1 will become 3 times. And I5, we will start a new branch here. I2, I1, 3, so I2 will become 7, I1 will become 4, and I3 will become 2. Okay. So now that we have constructed the FP tree, we have some definitions about the FP tree before we continue with identifying our frequent patterns. So FP tree is a frequent pattern tree, and it's actually a tree structure that has one root, and the root is labeled as null. Okay, now from the null we have a set of item prefix subtrees as children for the root null. Okay, so item prefix subtrees are actually the trees that branches from null, and frequent item header table, which means that each item will have its frequency. Okay, and we will see how these are going to use in order to identify our frequent items. Each node in the item prefix subtree has three fields. So it has the item name, okay, which represents which item belongs to this prefix. The count, which is the number of transactions represented by the portion of the path reaching this node. And we have the node links, which are the arrows that link between the node and other nodes. Each entry in the frequent item header table has the item name and the head of the node link. Okay, the head of the node link that actually points to the first node in the FP tree that carries this item name. And we will see these in a minute in the following tables. Now, the most significant advantage of the FP tree is that we only scan that dataset, as I said, twice. Another advantage of the FP tree is that it is complete, meaning that all frequent patterns in the dataset are represented in the tree. A third advantage of the FP tree is its compactness, meaning that the size of the tree the size of the tree is bound by the occurrence of frequent items. So how big the tree goes is actually uh, about, or it shows the frequency of the different items. The highest or the height, I mean, the height of the tree is actually representing the maximum number of items in the transaction. So in this case, in our case, the height of our tree should be 7 because the highest or the maximum number of item in a transaction is I2, and it happens 7 times. Now we go to how do we generate, or the idea of divide and conquer, how do we generate frequent patterns from the FP tree structure? In order to do that, we will be recursively growing the frequent patterns by looking into the paths. How do we get to any of the nodes by starting from the null root? So first of all, we'll be constructing conditional pattern base. And the second step, we're going to generate the conditional FP tree, which is actually our frequent patterns. To construct the conditional base pattern, we will be listing all the items in the tree along with their conditional pattern base, meaning along with their path from null. Notice that we have I1, I3, I4, and 5, but we don't have I2. And the reason for that is I2 does not have a path. I2 comes directly from the null node. It does not have a path. That's why it's not included here. Now, I5, in order to reach I5, we need to come from I2, I1 once, and I2, I1, I3 once, and we get this from the tree. And in order to construct the conditional FP tree, we actually combine similar items together. So I2, I2, 2, and I1, and I1, 2. I3 happened only once, so we'll be removing I3 because I3 is um, or its frequency is less than the minimum support. It's less than 2, so we'll ignore it. Now again, I4, how do we reach I4 from the tree? I2, I1 once, and I2 once. Now we combine together I2 happens twice, so here is it. And then we have I1 happening once. We will ignore it again because it is less than the minimum support. For I3, here we have a special condition. We notice that I3, we can reach it from the left side tree and the right side tree. So we'll have to list them separately. These two here, represent the paths from the left tree. I2, I1 twice, and I2 twice. And this one here represents the path from the right side of the tree. I1 twice. Now we combine similar items. I2, I2, 2 plus 2, 4, so I2 4 times. I1 2 times, but we will not combine it with this one because it is from the other part of the tree, the right part of the tree, so we'll leave it as it is. And we will combine them together later. For I1, we have only one path, I2 4 times. To generate the frequent patterns, we will be joining the items with the conditional FP tree. And joining means that we will first join I5 with the first item, so I5 with I2, and then I5 with I1, and then I5 with I2 and I1. So we get I2, I5 twice, I1, I5 twice, I2, I1, and I5 twice. Here again, I4 and I2, so it becomes I2 and I4 twice. Here, remember that this is the right side of the tree and this is the left side of the tree. So I3, it will go with I2, so I2 and I3 4 times. I3, it will go with I1, so it's going to be I3 and I1 2 times. And now I3 and I1, also I3 and I1 2 times. This is why we'll have I1 and I3 4 times. Now, if we want to combine them all three together, we will have I3, I2, and I1 only 2 times. If we did not do that split, this one here will become 4, and this is a mistake. If you go back to the data set, you will not see I2, I1, and I3 happening more than twice. And also here I1 and I2 4 times, so I2 and I1 occurred 4 times. And this is our frequent patterns generated from the same transaction set. So this is the summary of FP growth. It is actually a very efficient data set, a very efficient algorithm to generate item sets, and it's actually transforms every problem into a problem that gets scanned only, or gets the data set scanned only twice. So it's a very efficient data set. You have two examples to exercise. The first one, this is here for the a priori algorithm, and here is for the FP growth algorithm. Have a look at them and try them, and just for exercise purposes. Thank you very much. Assalamu alaikum.